Pleasant and good day everyone. So in this video, we will discuss about designing a DNS space and understanding the architecture and best practices. So in this video is the agenda, introduction to DNS, understanding DNS architecture, steps in designing DNS space, naming conventions, best practices and security, and conclusion. So first we're gonna tackle about the DNS, the introduction to DNS. So what is DNS? So DNS stands for Domain Name System. So what it basically do? So it will translate the domain names into IP addresses. For example, www.example.com or /192.0.2.1. So why DNS matters? So it makes the internet user friendly by mapping names to IP addresses. So designing a DNS or domain name system space involves organizing and structuring the namespace of an organization or network to ensure efficient, scalable, and secure domain name resolution. So DNS is critical because it translates human readable domain names. For, ex- for example, example.com into machine readable IP addresses which computers use to identify and communicate with each other. So DNS architecture. So here are the components of DNS architecture. First is the domain name, IP address, name server, and resolver. The other one is DNS zones, the root zone. So there are some TLDs, second level domains, and are also known as SLDs. So what are the TLDs? The or with or top level domain. So TLDs is decide it can decide whether to use existing TLDs, for example .com, .org, .net, or set up your own internal TLD. For example, is .corp, or slash .internal. So the second level domains or SLDs. So the other is then is DNS zones. So zones can divide your DNS space into multiple zones. So a zone is an administrative area managed by a DNS server. For example, the the example.com zone might include all the DNS records under example.com, such as www.example.com.mail.example.com. So zone transfers. So it will ensure proper configuration of zone transfers. So the process of copying DNS records from the primary to the secondary DNS server for high availability. So next slide is steps in designing a DNS space. So define first step is define organizational structure. The second is select domain name. Then the third step is choose name servers and last but not least is configure DNS records. So there are four key components of a DNS design. So the first one is namespace. Organizing domain names hierarchically. Then second is DNS servers. So authoritative primary and secondary DNS servers. The third is zones, administrative units within a DNS space. Then the last one is DNS records. So mapping of domain names to IP addresses. Next slide is DNS naming conventions. So what is the work of DNS naming conventions? It's a future proof of naming. You can keep it simple and descriptive. You can use hierarchy. So the example is eg underscore mail dot example dot com. So is DNS naming conventions important? Yes, it's also the key component in making a DNS. So the consistency and naming conventions can establish clear naming conventions for subdomains to ensure consistency, clarity, and predictability. So what is DNS record types? So as you have seen in this screen, that is the example of DNS record types. So best practices for DNS designs. It has high availability, GUDNS, TTL management, performance monitoring. So the best practices for DNS designs also includes scalability. The design should support growth as new domains and subdomains are needed to be added. So the second is the performance. So it can optimize for making the DNS making a fast DNS resolution with low latency. So the third one is security. So it ensures the protection against DNS based attacks. And the last one is resilience. So it will ensure the high availability and reliability through redundancy and failover mechanisms. So, in summary of that, designing a DNS space involves organizing domain names in a way that ensures efficient resolution, security, and scalability, while considering factors such as namespace hierarchy, server configuration, redundancy, and security measures. So, moving to next is the security considerations. So when you encounter some malicious activities, just report the incident to authorities or contact IT support or technical assistance. The third is change password and monitor account activity. Then four, DNSSEC for security. Avoid single points of failure, so DDoS protection. So what does DNSSEC mean? So DNSSEC means Domain Name System Security Extensions. So it will protect against spoofing and tampering by signing DNS records. And it also has an access control. It can restrict who can update DNS records. Then the other is DNS-based attacks. It can protect against cache poisoning or DDoS attacks. And it also secure DNS servers with firewalls and monitoring. So it is also that there are also common DNS design mistakes, and the example is of that is overcomplicating hierarchy, using and the other is using low TLS and not implementing DNSSEC and lack of monitoring. So the last part is the conclusion and the key takeaways. So DNS is essential for internet function. Then good design consider structure, performance, security. Then the next steps is plan your DNS architecture thoroughly. So DNS design is critical, but it will ensure your organization digital presence is reliable, scalable, and secure. And the other key considerations is the namespace structure, redundancy, security, and performance optimization. So the final thought is proper planning in DNS design will improve overall network efficiency and reliability. And also, this structure provides a comprehensive overview of DNS space design that you can turn into slides with visuals, diagrams, and key points. So I guess that's all. Thank you for listening and goodbye.